Sorry guys, we had some minor little technical difficulty. Welcome to part 2 of this video series for today. And what I want you to do as a group class project right now, I actually want you to go in and solve the following equations. In this case, we're going to add a couple of fractions together so you can get used to adding fractions that have the same denominator. So in this case, I want you to add for number 1, 5/3 plus 3/3. For number 2, I want you to add 4/9 plus 3/9. And for number 3, I want you to add, in this case, 3/8 plus 2/8. Okay, in your seats as a class right now, take 5 minutes to quickly do these problems on your screen, or excuse me, on your desks. And when you're all ready, at this point, Professor Speck, you can pause this video, and what we'll do at that time is, once everyone's completed these 3 problems, we can now go through and see the solutions for them. So again, at this time, you can pause this video. Okay, great. So now that you've all had a chance to work these problems out, let's see what the solution is in this case. So if you look at the first problem, 5/3 plus 3/3, again, because in this case our denominators are both one and the same, we can simply rewrite this problem as follows. We bring the 3 over, and we take our 2 numbers on the top and just simply bring them over by writing 5 plus 3 over 3. So we took 5/3 plus 3/3 and we wrote the problem as 5 plus 3 over a third, which gives us 8/3. Again, for the purposes of right now, you don't need to take this into lowest terms, or we can divide it and convert it into a fraction. That's later on today. But for right now, the answer that you should have gotten is 8/3. For number 2, again, we're going to do the same exact thing. Again, our denominators are one and the same. They're all 9s. So we're just simply going to rewrite this problem as 4 plus 3 over 9. Again, that's because, again, the denominators are both one and the same. And this problem can be solved by adding 4 plus 3, which is 7, over 9. So 7/9 is the answer that you should have gotten for number 2. Last but not least, we will apply the same principles for number 3, where we will rewrite the problem as 3 plus 2 over 8. And that gives us 5/8. So from an answer perspective, this is what you should have gotten for all 3 of the problems that should have been worked out in class at this time. Now, the next thing I'd like to talk about is what happens if we're subtracting fractions. Are there any other rules or considerations that we need to think about? Well, the good news is, when it comes to subtracting fractions, the same exact rules apply as in addition. So if I have here, oops, sorry, let me just bring up the brush here. If I have 5/3 minus 3/3, again, my denominator are both the same. They're both 3, so I'm just going to move the 3 over, and I'm going to rewrite this problem as 5 minus 3. 5 minus 3, which gives us 2/3. Again, the same principles apply here, except that now you're subtracting. So if I do one more, if I write 6/9 minus 2/9, again, I can rewrite this problem as 6 minus 2 over 9, which now, again, 6 minus 2 is 4, so this becomes 4 over 9. Now, at this time, what I'd like for you to do is to take the same exact approach and do the following 3 problems at your desk. So at this time, what I'd like for you to do is to do problem number 1 at your desk, which will in this case be 5/10 minus 3/10. For number 2 at your desk, I'd like you to do 4/8 minus 3/8. And for number 3 at your desk, I'd like for you to do 9/12 minus 3/12. Again, Professor Speck, you can pause the video at this time so that our students have an opportunity to work on these problems at their desk. Okay, great. So hopefully you've all had a chance to work on these 3 problems. So let's talk about what solutions you should have received or you should have come up with when solving these 3 problems. So for the first one, I'm going to rewrite this problem. Again, the first thing I should note is that pick a brighter color here, my denominators are the same. So I'm going to simply rewrite this problem as 5 minus 3 over 10, which now becomes 2/10. And for those of you that know about reducing, we know that 2 and 10 actually can be divided or reduced down by 2. And the reason is, if I look at this, both of these numbers are even. And because the 2 is even, the 10 is even, that means I can divide both sides by 2 and reduce this fraction down. So if I were to divide both sides by 2, what I can do at this point is 2 divided into 2 is 1, and 2 divided into 10 is 5, so I can reduce this down into 1/5. Again, we simply just subtracted the problem, we brought the 10 over, and in this particular example, we simply rewrote the problem as 5 minus 3 over 10. We ended up with 2 over 10, but because both numbers were even and divisible by 2, that means I can divide both sides by 2 to reduce this fraction down to its lowest possible term. So when I divide the top by 2, 2 into 2, or 2 divided by 2 is 1, and 2 divided by 10 is 5. And if I want to check myself, okay, if I were to simply take that same number and say, if I were to multiply 2 times 1 and 2 times 5, I should end up with the same fraction that I had before I reduced it, which I do. So in this case, I know that the correct answer, in this case right here, is going to be 1/5. Now, let me just quickly erase some of this so that we can do the rest of our problems. Alright, so if I look at the second problem, this is 4/8 minus 3/8, and again, my denominators, okay, I'll just have to choose the right object here. My denominators are both the same, they're both 8s. So I'm going to rewrite this problem as follows. In this case, it's going to be 4 minus 3 over 8, which becomes simply 1/8. And this is the correct answer that you should have come up with. When I look at number 3, again, the same principle applies here. I have 12s on the bottom, so I'm going to rewrite this problem as 9 minus 3 over 12. And this gives us 6/12. Now, if you know your multiplication tables, you know that 6 times 1 is 6 and 6 times 2 is 12, which means I can divide both sides here by 6. So if I divide both sides by 6, what I end up with is 1/2. This is the lowest possible term that I can reduce the fraction 6/12 down to. And again, as a rule, you should always consider that you can reduce fractions down to the lowest term if you can divide the bottom and the top by the same number. So because 6 and 12 are even numbers, I could have gone the route of dividing both sides by 2, but in this case, if I just do some simple multiplication, 6 times 1 is 6, 6 times 2 is 12. Well, guess what? I have a 6, I have a 12. That means I can divide both sides by 6 and reduce it down to its possible lowest term, which in this case is a half. Okay, so for the next 5 minutes before we end this current section and go on to the next one, so far I've shown you two problems, how you can add fractions and how you can subtract fractions. But we've talked about examples where the denominators are both one and the same. What happens, however, if that isn't the case? What if I gave you a fraction such as 1/3 plus 2/6? Well, this is a problem because now I have to ask myself, well, both the numbers, my denominators, are not the same. They're not the same, and therefore when this happens I have to come up with what we call the lowest common denominator. Okay, I'm just gonna hopefully fix that. Okay, you know what, let's do this. Alright, so let's put the actual text here, which is when you have two fractions that do not have the same denominators, we must find what is called the lowest common denominator. And that is the lowest common number that is common between my two denominators. Now, one of the easiest ways that you can do this is to simply look at your 3 multiplication tables and your 6 multiplication tables to see what is the first instance in which there are values in both sides. And let me show you what I mean by that. So how do you find a lowest common denominator? So in this case I have a denominator of 3 and another common denominator of 6. So I need to find a number that is common between 3 and 6. So the first thing I'm going to do is I'm going to write the 3 times multiplication table. I'm going to do a couple of them. So as you can see in this case right here, I simply just went in and wrote a couple of my multiplication tables for 3, which is 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, and so forth, all the way to 3 times 7 is 21. Now I also went ahead and I wrote the 6 times table. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 24, etc. And when I go through this, the first thing that I notice, again, I need to find the first instance on both sides where the answer is the same. In other words, the first thing I'm going to look for over here on the right, I'm just going to highlight this for a moment. I'm going to ask myself, is there a 3 anywhere in this table here? And the answer is no, there's not. However, what I will notice is that if I look at this very closely, there are a couple of instances when I do see, in this case, a value that matches. If I look over here at 3 times 2 is 6, and then I have 6 times 1 is 6, this is the first time where I have values that are the same, 6 and 6. So what this tells me is that my lowest common denominator, in this case again, my lowest common denominator for this problem is going to be 6. So what I'm going to have to do is rewrite the problem using the lowest common denominator. And what we're going to do in the next part of this video is show you how you can take that lowest common denominator and ultimately use it to solve the problem. So again, when you have fractions that do not have the same denominators, you must find the lowest common denominator. And the way we do that very quickly is that you take your first number, in this case 3, I write out the multiplication table for a couple of problems, do the same thing for 6, and find the first instance in which I have answers that match, in this case the number 6. That's the lowest common denominator, the first time that I see the same numbers on both sides. And this is what we're going to use to solve this problem.